The National Electrical Code, specifically the 2017 edition, addresses the placement of switches in relation to bathtubs and showers to ensure electrical safety. This regulation aims to minimize the risk of electrical shock by preventing individuals from operating switches while in contact with water. The primary requirement is that all switches installed on bathroom walls must be located at a minimum distance of 3 feet, measured horizontally, from the edge of the bathtub or shower stall. This 3-foot zone, often referred to as the restricted zone, is designed to prevent a person standing in or near the tub or shower from easily reaching and touching a switch. The rationale behind this code is based on the understanding that water significantly increases the conductivity of electricity. When a person's hands are wet, the body's resistance to electrical current decreases, making them more susceptible to electric shock if they come into contact with a live electrical component, such as a switch. Placing switches outside of this 3-foot zone reduces the likelihood of simultaneous contact with water and electricity. It's important to note that a 3-foot distance is a minimum requirement. In practical applications, it is often advisable to increase this distance whenever possible to further enhance safety. Factors such as the size and layout of the bathroom may influence the optimal placement of switches. Firstly, the type of switch also matters. The code primarily addresses standard switches. However, other types of controls, such as dimmer switches and fan speed controls, are also subject to the same distance requirements. Secondly, the height of the switch is not explicitly specified in relation to the 3-foot rule, but it is generally recommended to install switches at a height that is easily accessible and compliant with accessibility standards. This typically means a height between 44 and 48 inches from the floor. Thirdly, the NEC also addresses the placement of other electrical devices in bathrooms, such as receptacles. Receptacles located within the 3-foot zone must be ground fault circuit interrupter, or GFCI, protected. GFCIs are designed to detect even small imbalances in electrical current, which can indicate a leakage of current to ground. When a GFCI detects such an imbalance, it quickly trips the circuit, cutting off the power and preventing a potentially dangerous electrical shock. The installation of switches and other electrical devices in bathrooms should always be performed by a qualified electrician who is familiar with the NEC and local electrical codes. These codes may vary slightly from one jurisdiction to another, so it is essential to ensure compliance with all applicable regulations. Failure to comply with these codes can result in safety hazards, electrical shock, and potential legal liabilities. The NEC is updated periodically to reflect advancements in technology and evolving safety concerns. It is crucial for electricians and homeowners to stay informed about the latest code requirements to ensure that electrical installations are safe and up to code. In addition to the 3-foot rule for switch placement, there are other safety considerations to keep in mind when dealing with electricity in bathrooms. Firstly, never use electrical appliances near water. Hairdryers, curling irons, and other electrical devices should be kept away from bathtubs, showers, and sinks to prevent the risk of electric shock. Secondly, regularly inspect electrical cords and outlets for damage. Frayed cords and cracked outlets can pose a serious electrical hazard. Replace any damaged components immediately. Thirdly, install tamper-resistant receptacles, or TRRs, in bathrooms, especially if there are children in the home. TRR have internal shutters that prevent objects other than electrical plugs from being inserted into the slots, reducing the risk of electrical shock. Understanding the principles of electrical safety is essential for preventing accidents and ensuring a safe living environment. Electrical current flows through a closed circuit from a power source, through a conductor, and back to the source. If a person becomes part of this circuit, electricity can flow through their body, causing an electric shock. The severity of the shock depends on several factors, including the amount of current flowing through the body, the path of the current, and the duration of the exposure. Even a small amount of current can be dangerous, especially if it passes through the heart or brain. Electrical resistance is a measure of how difficult it is for electricity to flow through a material. Materials with low resistance, such as metals, are good conductors of electricity, while materials with high resistance, such as rubber, are poor conductors. The human body has a relatively high resistance to electricity when dry, but this resistance decreases significantly when the skin is wet. This is why it is so important to avoid contact with water when working with electricity. Grounding is a safety measure that provides a path for electricity to flow safely to ground in the event of a fault. Grounding systems are typically connected to a metal rod buried in the earth. If a live wire comes into contact with a grounded metal object, the electricity will flow through the grounding system to ground, tripping a circuit breaker or fuse and cutting off the power. Ground fault circuit interrupters, or GFCIs, are designed to detect even small imbalances in electrical current, which can indicate a leakage of current to ground. When a GFCI detects such an imbalance, it quickly trips the circuit, cutting off the power and preventing a potentially dangerous electrical shock. GFCIs are required in bathrooms, kitchens, and other areas where water is present. Circuit breakers and fuses are overcurrent protection devices that are designed to protect electrical circuits from damage caused by excessive current flow. When the current in a circuit exceeds the rated capacity of the circuit breaker or fuse, the device will trip or blow, cutting off the power to the circuit. This prevents the wires from overheating and potentially causing a fire. Electrical codes are sets of regulations that govern the installation and maintenance of electrical systems. These codes are designed to ensure that electrical installations are safe and comply with industry standards. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It is updated every 3 years to reflect advancements in technology and evolving safety concerns. In the context of bathroom safety and switch placement, several sections of the NEC are particularly relevant. NEC Section 210.8 addresses ground fault circuit interrupter protection for personnel. The section requires GFCI protection for all 125-volt, 13 and 20 amp receptacles installed in bathrooms. The requirement for GFCI protection extends to receptacles located within 6 feet of the outside edge of a sink. NEC Section 404.4 addresses the location of switches. This section specifies that switches shall not be located within wet locations in showers or bathtubs unless specifically listed for such use. While the code does not explicitly state the 3-foot rule, the interpretation and enforcement of the section have generally led to the establishment of the 3-foot zone as a standard practice. NEC Section 406.9 addresses receptacle placement in bathrooms. This section states that receptacles shall not be installed within a bathtub or shower space. The key takeaway from these NEC sections is that electrical safety in bathrooms is a multifaceted issue that involves careful consideration of switch placement, receptacle protection, and overall wiring practices. Firstly, ensure that all electrical work is performed by a qualified electrician. Secondly, always use GFCI protected receptacles in bathrooms. Thirdly, never install switches or receptacles within the immediate vicinity of a bathtub or shower. The 3-foot rule is a practical guideline for maintaining a safe distance between switches and water sources. Understanding basic electrical principles and adhering to the NEC are essential for preventing electrical accidents and ensuring a safe living environment. The principles of electrical safety are based on understanding how electricity works and how it can be dangerous. Electrical current always seeks the path of least resistance. If a person comes into contact with a live electrical conductor, electricity can flow through their body, causing an electric shock. The severity of the shock depends on several factors, including the amount of current, the path of the current, and the duration of the exposure. Even a small amount of current can be fatal. Water is an excellent conductor of electricity, so it is essential to avoid contact with water when working with electricity. Never use electrical appliances near water, and always dry your hands thoroughly before touching electrical devices. Grounding provides a path for electricity to flow safely to ground in the event of a fault. All electrical circuits should be properly grounded to prevent electrical shock. Ground fault circuit interrupters, or GFCIs, are designed to detect even small imbalances in electrical current, which can indicate a leakage of current to ground. When a GFCI detects such an imbalance, it quickly trips the circuit, cutting off the power and preventing a potentially dangerous electrical shock. GFCIs are required in bathrooms, kitchens, and other areas where water is present. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. When the current in a circuit exceeds the rated capacity of the circuit breaker or fuse, the device will trip or blow, cutting off the power to the circuit. This prevents the wires from overheating and potentially causing a fire.